So the first thing I would like to discuss, if you remember the first function we mentioned about the BDCP buffer. Once the packet received from the TCP IP or from the upper layer in general towards the BDCP, like assuming this can be downlink or uplink direction, both have the same. You will find that once the packet received at the buffer, this packet, there will be a timer associated for each packet called the SCAR timer from the GNB side or from the U side. This can be configured for both of them, but you can check it from the drive test or layer 3 for uplink only. Downlink is already configured at the GNB side, and this is part of the they call it flow control from GNB especially. So once the packet arrives, it will be starting this timer. So for example, assume that you have this timer is 1 second. So assume the packet arrived and it stayed in the buffer for more than 1 second. For example, it's being transmitted and somehow it's being failed within the air interface. For example, move to RLC and MAC. So it keeps, for example, doing retransmission, and it couldn't be like, for example, it couldn't be acknowledged by the other layers all that time. So the BDCP will not move it out of the buffer unless the packet is being acknowledged and transmitted from BDCP to lower layer and acknowledge it from the lower layer. So assume that the packet is one second, and till 1 second, this packet still there, or whatever packet is still there. This packet will be discarded after 1 second if it's not acknowledged again by the lower layer. And sometimes, as mentioned by 3GPP, if you read the description here, when the discard timer expires for DCB SDU or the successful delivery, see, these two things can discard the packet. Whether there is a discard timer expired for the BCP or the successful delivery being done. If the successful delivery being done, the packet will be discarded from BCP. It's not anymore needed in the buffer because it's already passed to the receiver side, so it can be discarded. But if it's unsuccessfully, for example, delivered and crossed the timer, then it will be completely discarded. But there is a side note and very important note you need to know. Okay, if you look into this note again from 3GPP here, let me zoom in just to have more clear example here. See, saying that sometimes the discarded packet will have already associated BDCP sequence number. Assume that you have packet number 3, packets with sequence number 3, and 1 and 2 being transmitted, and 4 as well. But only packet sequence number 3, it's transmitted to a lower layer, but it's not acknowledged. So in case if this one discarded because of the discarded timer, assume the discard time is very low, so this can cause a gap in your flow, right? Can cause gap in the sequence number. This means the receiver will be receiving sequence number 1, 2, and 4. So this 3 will be already discarded from BDCP layer. So this will be starting the reordering at the receiver. So this might cause like a delay to the packet delivery from the BDCP to the upper layer. We'll be discussing about the reordering, but whenever you have out of order packet received at the receiver cannot forward these packets to upper layer, which is TCP IP. So this can cause a lot of, or a very high, for example, latency, especially if the reordering timer is very high, because within this reordering timer, the BDCP receiver will try to rearrange packets and send it in sequence to the upper layer. Okay, so this is just as a side. So yeah, so that's why here there is multiple consideration you need to consider. First of all, this timer should be very low, for example, to allow for example to allow retransmission if it's happening to be completed. So it shouldn't be very low. It should be, for example, matching with RLC, especially for the uplink and even downlink, matching with RLC transmission to allow, in case of the packet being retransmitted within the lower layer, to give it a chance to complete the retransmission before it's being discarded by the BDCP. Because if it's discarded, this means the packet is lost, or it's considered as a packet loss. And also from the upper layer here, this is like before going to TCP in next session, there is also a retransmission timer. It's called RTO, but this it's like this timer have initial value, then it will change dynamically based on different things I will be discussing in details. But assume that from the TCP itself, it having this RTO timer, usually the initial value was 1 second. This from TCP side, if the packet, any packet will be transmitted, it will start a timer called the retransmission timer, which is initially start as a first transmission with 1 second. So assume, for example, this packet, this timer here is 500 millisecond. And during this 500 millisecond, the packet was not being acknowledged or not being transmitted. It stayed in the buffer. So this means it to be discarded. Once it discarded, this means here he didn't like this means the TCP IP will even do the retransmission, because this already BDCP, this will be considered as packet loss, and this will be delivered to TCP that this packet is being discarded. So this will be early discarding for the packet. So usually, for example, we need to consider what is the, for example, let's assume this one is 1 second. So this, for example, can be 1 second as well to try to match it. This is just like a logical thinking, okay? This is the main consideration here. Let's move to the next function, but this was the first parameter and function which related to the BDCP buffer, okay? And BDCP buffer is being controlled by something called BDCP discard, and this is like under the flow control. And also the advantage of discarding the packet that sometimes you have a very high load in the network, so keeping the packets for very long time in the buffer, this can impact your capacity and load as well. So you need to have a kind of a compromise whenever you tune this timer between the retransmission and also the network load. Let's move forward and see what we have for the next function. Next part here, actually, this is related to the second part. If you remember, I was discussing about the BDCP header compression in general. I already discussed this one of my videos. You can refer to the VoLTE, for example, BDCP or robust header compression. It's exactly the same concept. It didn't change. I will quickly go through it, but if you would like to go through details, you can also check this video. So the header compression as well, it's optional. It can be enabled or disabled, as I mentioned in the very beginning. And usually this is like the main idea. It reduces the packet size. And reducing the packet size also can improve the capacity, and it also can improve the block error rate, because you will have more power per resource element. If you have less size of the packets, this means you can have more power per resource element. So here, the idea that of data compression, you can see that the compressor, the transmitter in general, will establish something called context, which is mentioned in the right here, or discussing here. Then the data, it will compress the data, then the data transmitted over the air interface will be like reduced. In general, the compression will like be reducing the number of bits transmitted over air interface. And this is usually especially for the small payloads, such as, for example, the voice over VoNR or VoLTE, of your speaking file, again, voice over IP, and also put the TCP acknowledgement. We'll be discussing about the TCP in the TCP part, but there is a TCP acknowledgement. This is usually having a less payload. So the header, usually the header of the IP is accounting around 60% of the total payload. So assume that you have 60%. You can completely, for example, the IP header usually for IP version 4, IP version 6, which was going to be decompressed. You can see that IP version 4 up to 60 byte, usually 60 byte, and IP version 6 is 40 bytes. If you decompress this one, this can go to only 3 bytes. So assume now if you have a low packets, this will be a very useful for that. So here the compressor like will be aligning with the transmitter with the receiver, like header compression was the compressing decompression functionality in the receiver. Here will be aligning this IP version 4 and 6 will be, for example, decompressed up to, will go reduced up to 103 byte. And just as a high level again idea here, how this kind of working. Initially, the transmitter, if having kind of this bits, assume 21xx01, 21xx02. So the compressor or transmitter will understand that there is a context here. It can be removed. For example, it will take out the bits 21xx. This will be the context, and it will be just transmitting the last bit here, which is 1, 2, 3, 4, 5, 6. So this is how it's being decompressed. It will just initially pass the first one only to allow the decompressor or the receiver to understand what is the context. So it will allow the first one as it is. Then it will again once establish the context, will just being transferring the last, for example, number here, as you can see. And this is how the output will be, and this is can reduce up like as you mentioned from, for example, 60 byte or 40 byte up to 1 to 3 byte, and this is very high compression ratio. It can go up to 70%, and this is very useful. Now let's move to the how to check this kind of things from the parameters. Okay, if you look into here, there's two things you need to check. If, for example, if you are going to enable the feature for voice over VoNR, or even for any other function, for example, like TCP/IP, you need to confirm two things. First of all, you need to verify whether the UE you are doing the test is supporting the compression or not, because sometimes the user itself will not be supporting this kind of robust compression. How to check that? You can through check the UE capability message from the RRC layer 3, and you will find under the UE capability message something called structure UNR capability, as mentioned here, BDCP parameters. This is all the profiles. For example, we have as the 3GPP, You have from profile 0 till 4, as you can 104 here. You'll find all the profiles here. Here, all is false. This means this particular device is not supporting. So this is the first part you need to confirm. And from the layer 3 itself, if you zoom in here, RRC configuration message. Once, for example, you're doing a test and it's being supported, if you enable the feature, you need to confirm under the RRC configuration message as well. You will open, you'll find data review period being added. Here will identify your QFI, which is MIXI, for example, and here is decided compression. For example, in this case, it will not use at all. It was like not used. Means that there is no header compression being used here. And in the bottom left example here, this is another one that's showing that it's being supported. As you look down here, for example, profile 1 and 2 is true. And this means that profile 1 and 2, which is used for voice over VoNR, was being supported here for this particular message. This is how you can verify it from the drive test.